Yes, dear face, we can start now.
Okay, sir.
Yes, please.
Good evening, everyone, and welcome to today's session. Throughout this workshop, we explored the foundations of artificial intelligence, machine learning models, and predictive analytics. Today, we will examine a powerful real world application of these technologies in the field of healthcare: brain tumor MRI classification. Medical imaging generates vast amount of data, and accurately interpreting that data is often critical for timely diagnosis and treatment. Machine learning and AI techniques are increasingly being used to assist healthcare professionals by analyzing MRI scans and identifying patterns that may be difficult to detect through manual observation alone. In today's session, we will explore how machine learning can be applied to classify brain MRI images, understand the workflow involved in image based prediction, and see how AI is contributing to advancements in medical diagnosis and decision support systems. This topic brings together several concepts we have discussed throughout the workshop, including data preparation, model development, classification techniques, and performance evaluation, while demonstrating their impact in a highly meaningful real world setting. Guiding us through today's session is our esteemed mentor and speaker, Dr. Meher Chand, whose expertise in artificial intelligence, machine learning, and applied computational research continues to help learners understand how modern AI techniques can be used to solve practical challenges across different domains. With great pleasure, I invite Dr. Meher Chand to kindly lead us in today's session. Over to you, sir.
Thank you, dear face, for nice introduction about the today's session, and welcome to all the participants in this session. And thanks to show your continuous interest in all the sessions. In the previous all the sessions which we discussed about the machine learning models, okay, and mathematics behind along with the different modules, algos, models, and Python concept also we try to cover. And I hope that all these sessions really will help you and enhance your skill and create your interest to use these machine learning models. And I hope that your interest related to AI has been increased. This is my opinion, and also I think you also have the same interest. Okay, so actually, some of the content, images, mathematics behind, which is highly useful. Partially, some part we have covered, and some I share the images only, essential part of the mathematics and how we can use. But other things which is essential mathematics for A and ML, we are not able to present because this is the only 15 days, 14 days workshop, and a lot of time is required to create the concept, then implement through the Python. Okay, and each step are required to understand. But beginning to since yesterday's lecture, other things, according to my opinion, going well. Some of the little bit questions are there. Okay, uh, I try to give answer, but sometimes uh, we have to we must have some examples related to the questions that can be easily interpreted. Okay, so today also the model which I am trying to present some of the concept which we have covered in the past are used here, and some of the questions this will model help you to understand. Okay, specifically related to the classifiers, matrices, etc. But here, one more thing, when we are working on the deep learning, actually we have the images. Okay, so when we have collected some images and suppose about 5,000, the data set is very heavy as compared to the numerical data set. Okay, so numerical data set we can easily upload, download in the Python. Okay, and then we can implement all type of the required models which are essential for uh, train the model. Okay, and testing, validation, etc. As we discussed in the yesterday's lecture. But in the case of deep learning, the data is very heavy. Okay, images are there to upload and download are very time consuming, as well as when we train the model, we are applying epochs, iterations. These are also very time consuming. As I told you that about I applied only 20 epochs, and for the 20 epochs, about 4 hours has been spent, and I continuously observing that when this will stop. Okay, so till now, just starting the before starting the session. Okay, uh, these epochs are successfully completed, but after that, some you can say some of the steps are also there which I want to follow, but our this is the timing to start the session. Okay, so let's see what happened. And also, one participant was asking about the hybrid machine learning models. Okay, that also I have, but I don't think that I can be able to present during this time. But I will share. Uh, you can easily go through and all the entire information for the hybrid and how we can use and what is the meaning of a hybrid when we apply 2 or 3 models altogether. Okay, one for the one specific part, and then for the second part we have for the another model depend upon the data set. Okay, so this type of machine learning models are hybrid. So that file I will share, and I think there will be no problem related to use. Everyone can use this file. So I am going to cover only one model, which is based on we have the some MRI data set. Okay, so brain tumor MRI classifications we are doing. So I required to share my screen. Okay, so yes, you can see this is my screen. My screen is visible. Yes. So this is the brain tumor MRI classification, and this notebook implement a deep learning pipeline for brain tumor classification using uh, transfer learning, pre-trained ResNet 50 from ImageNet, and explainability. We can say the line local interpretable model agnostic explanations. So these we are using. So before using this, I would like to show you the data set. Okay, this is my local directory, and here you can see these are the 4 set. These are the 4 classifications. Okay, one is glioma, and when I will click on it, and you can see there are several images are there. Okay, when you will click, you can see on the right hand side, this is one of the image of a tumor. Okay, and these are the set of the images. Also, you can see on the right hand side, all these are different images from the different angle. Okay, so various images are required. So all the set which you can see here. Okay, this is the another one. Okay, this also contain the images. Okay, you can see for different portion of the body. Okay, You can see. And then no tumor. This is the image of no tumor. Okay, you can see. These are images of no tumor. Yes. Okay. And then we can have pituitary. Okay. When you will click on it, this also contain some more images. Okay. So I'm not going through the more detail about the literature behind the tumor and the images. Just how you can apply deep learning model, okay, when you have the collection of the images. So here you can see there are two categories of the images. One is just one minute. Yes, tumor. So there are two sets. One is the testing and other is training. Okay. So one data is used for the train and the other data set is used for testing. So these are two set of the data set. Okay, and both have the same classifications. Yeah, if you will open this training, this also contain four set. Okay, same as we have the testing. Okay, and as you know, for the testing we are using 20%. So most of the things which we use for machine learning model, and you will find here similarity. Okay, so see here, now come to here. These are the classification task for the brain tumor type. First class, first in the first column you can see the glioma.
Sir,
Type is brain tumor. Yes, please.
sir, what is the criteria for selecting all these image sets, sir? So you have taken the 4 sets of images, no, sir? Did you
Pardon?
know, sir, how we are taking all these 4 sets for training and testing? So the process,
Yes,
sir.
we will cover all this. We will cover during the
Yeah.
session. Yeah. Okay. So we have the class just like glioma, brain tumor, and the description you can see the originate from glial cell. Okay. Then we have the meningioma. Okay. This is the membrane tumor. A tumor is in the protective membrane. No tumor, normal scan, healthy brain tissue. Okay. And last one we have the pituitary. Okay, this is the also the type of the tumor and tumor in the pituitary gland. So these are the four categories which you can see. Okay, and if you will see the first one, so are the images from the different angles, different size, from different distances. Okay, are inside in this group. Okay, similarly we have the in each class you can find. Okay,
Here
so
our side is, sir. So how did you know to select these data sets, sir? How did you know? How did you know to select
yes,
these data sets? The fundamental thing here, what are the data sets we have to select? Selection of data sets we need, sir. How to select data set? What is the criteria for selecting a particular data set? So RSNet 50 you have selected, sir. Why did you select RSNet 50? Why don't you select VGG 16 or some other neural networks? Here the basic thing is we are selecting data set and we are selecting randomly the neural network. We are training and we are getting the accuracy and sensitivity like that, sir. But here, what is the fundamental thing to select a particular data set and a particular neural network to training and testing? These are things I need, sir.
yes, we will cover all these things. Okay, actually here in the previous machine learning model which we covered in the previous sessions, those are basically based on the numerical data set. Okay.
Yeah.
In that case, we are using only the machine learning models. But right
Model.
now, we have some more features in the data set. Actually,
Yeah.
when we have the images, so for one type of the disease or for one particular tumor, we can have the image from different angle, different size. Okay, so uh, in that case, we have to apply deep learning. Okay,
Hmm.
artificial neural network. The
This is a
mainly is
CNN. We have to use CNN, sir. Convolution neural network.
yes.
So the architecture we have to know, sir. The what are the layers are there? What is convolution? Uh,
Uh, yes, please. Just wait.
yeah,
Actually, yeah, please keep patience. During the session, we will cover. Okay.
yeah.
Yeah. Yes, please. So first, we are going to discuss about why we need deep learning. Okay. What are the process and how we can choose. So all these will be step by step during the session. Actually, I told you that a lot of time is required to prepare to check this file only. Okay, so we will cover all the questions, and if there will be, I will try to justify your questions. Okay, so first thing is to set up the environment. Okay, so we are required TensorFlow Keras for the deep learning and transfer the learning. Okay, OpenCV for the image processing. So these are the some modules and the packages which are required. NumPy and Pandas, we are already familiar about these two libraries for numerical and tableau operations. Scikit-learn also we use in the machine learning models for matrices and dataset utilities. Matplotlib and Seaborn we are using for the visualization. And Line will help explainable AI. Okay. So these are the some packages which are essential. So you are required also to install, just like OpenCV, you have to require to install in your system. Okay, so the command is put here, but I will not execute any command right now. Actually, the thing is, if I will start to execute the commands which are available here, lot of time is required. Okay, so till the approach which we apply, I have to spend 5 hours. Okay, so if I will execute all the statement one by one, then lot of time is required. Actually, this entire part require to complete, we are required 3 to 4 days. So we are going to cover the same thing within during this time only. So very less time we have. Okay, so just you have the idea how we can apply the deep learning for image processing. Okay, classification. So these are the libraries which you can see. You are also required to install uh, mbutils, okay, and then TensorFlow, okay, and install Line. Line will help you to understand the AI. Okay, so these libraries which are not available in our system along with Anaconda, we have to install, and then after that's why I put these install statement in the beginning so that you can install and then you can come to this place. Yes, this is the environment setup, which will include all the libraries and the packages, import OS, which is used for operating system, and import time, import pickle. Pickle is used for the to pick the different images. Okay, warning. Sometimes when you will execute the algos or the sometimes we have the warning. So to control this, we have to use warning. And also in the previous session, we use same and import random, import CV2. Then we have the data manipulation and analysis. So these are the libraries which we are using for manipulation and analysis. And these are the libraries which are used for visualization. And then we have the machine learning evaluation. So we are importing here from sklearn.matrices import. So all these classification report, confusion matrix, accuracy score, precision score, recall score, F1 score, all these we have discussed in the previous sessions. Okay, and also we are using here label encoder to encode the label to the images. Okay, and then these are the some deep learning TensorFlow keras, which are essential for deep learning. So from the TensorFlow ASTF, and then we are required to import here model TensorFlow.keras.model import model, and then we have the layers. These are the layers. Specifically, these are the hidden layers which we have used, which are essential for our deep learning. So these are the some names: dense dropout, batch normalization. Okay, then we have the first one. We have the global average pooling 2D, and TensorFlow.keras application import Ranset 50. So all these are the libraries and the modules for deep learning. Then explainability line, okay, that is used for we are required to from line import line image, and from sk image dot segmentation from mark boundaries. Okay, so actually the images have different features about what are the on the boundaries, what are inside the, which type of the features are there. So all these will help to study the patterns inside the image. Okay, so if there are so press the warning. So warning library also we have import here, and if there is any warning, this will suppress. Okay, so when we will execute what this will do, so you can see the environment setup equal to uh, 70. Then all the libraries imported successfully. Okay, print F version information, TensorFlow. Okay, NumPy. So all the versions are there, which you can see. This will return the which type of the versions are there with respect to all the libraries which we are using here. Okay, so this is the complete environment which is essential part for deep learning. Okay, so when you will execute, you can see the all the libraries imported successfully: TensorFlow, NumPy, Pandas, hardware information also is there. Okay, TensorFlow GPU support is not available on the native window for TensorFlow. Okay, 2.11. Even if CUDA or Pseudon are in the GPU available fast. Okay, so some of the for this one we can use the GPU from localhost. Okay, but if you have the more data set, then we have to integrate to make uh, to extract the output values. So here you can see the configuration and the hyperparameters. So hyperparameter configurations, image size. Okay, so determines the input resolution, page size, affect the memory uses, and gradient stability. Actually, the mathematics behind the gradient and gradient stability and how we can use this part is missing from me side. Okay, the content I was not able to provide you, but this is very essential when we are employing artificial neural network. Okay, so epoch define the training iterations. Epoch means how many iterations we are using, and learning rate control optimization step size. Okay, so usually as yesterday we talked about the learning rate, the value of eta, which is 0 0.1, then 0.01, 0.001. Okay, in this way we can choose the learning rate. So here, when you will apply the pip install, actually Kaggle Hub, you can see here the data set which we are using for here, we are taken from the Kaggle. So how many people are familiar about the Kaggle?
Yes, sir.
Are you familiar with the Kaggle?
Yeah.
It provides the data sets.
Yeah, the Kaggle provided the data set. Okay, so from the Kaggle, there are a lot of data set is there, and according to for our training part, or if we don't have the data set, we can access data from Kaggle. Okay, various type of the models are there. So for the learning purpose, and along with the coding part is also there. Coding is also there. Okay, so if you will see, this is the Kaggle. You have to create your account also. Okay, and then after you can, this is the link. Okay, so Kaggle, the words AI providing ground. So from this place you can have the data in CSV or the images format, whatever you need for the learning, you can access from this one. Okay, just you are required to register here, and then after you can, various examples are there. Okay, now you can, you are able to use the depository for learning purpose, for training, and various examples are there, and this is completely open source depository. Okay, so this data set which we are using here, we are taken from the Kaggle. But if you want to use this depository directly in your system, you have to install this Kaggle Hub. Okay, so you are required to install this library, and when this will be installed in your system, then after, here you can see we are able to now import the data set. Okay, so the centralized configuration for AC modification, track overall program execution time. So here program underscore star time dot part underscore counter. Okay, and here is the,
Sorry for disturbing, sir. Sir, can you
yes,
click on that hide option, sir? There is a
my,
pop-up which is showing.
pardon?
On your screen, there is a pop-up. Stop sharing and hide. Can you click on that hide option, sir? Yeah, sir. Thank you.
Yes, it's okay.
Yes, sir.
Okay, so then after we are required to import Kaggle Hub. Okay, now after that you can see download the latest version. So this is the Kaggle dot dataset underscore download. This is the dataset. Okay, name where this dataset is available. You can see in the code sign. So this will automatically directly download this dataset at this place. Okay, and then after we can use.
Sir, can you
So,
show that name in Kaggle, sir, once where it might be present? Because this name should be same thing should be matched now, sir, from Kaggle also.
Same thing in the Kaggle. I have to use another account. Okay. You can use this name only, brain tumor MRI dataset. Okay, so when you will come to this place, Kaggle. So you can see here a brain tumor classification. You can see this link. Okay, you can open it, and also, yes, this one. So here also you can have the different data set, brain tumor MRI image for 4 classes. Okay, so from this place you can easily access the data set, and also you can download different type of the models which are available. If you will click on it, yes, you can see brain tumor MRI dataset. Okay, so from this place you can download, and also you can download, you can use it directly. And here is the coding part is also you can find here.
No, sir. What I'm asking is in that Python code, you kept that MRI images data set, you kept something right now, sir. So is that should be matched with the Kaggle data set, or whatever the data set we require, we can give in that code. That's what I'm
Sir,
asking.
actually, yes. Actually, right now, the data set which we are using, that is from the Kaggle. This one. This data is using from Kaggle. Okay. If you want to use the data set from your system, if you have, we can use the same to import at the place, and then we can process the same steps. Okay.
Okay,
You,
sir. This
okay.
this
So
data set is present in your system. So you are keeping whatever the system name is available, that the file name you have given here.
yes.
What I'm
Right.
asking is, if I am
Yes.
accessing the data set from the Kaggle, directly from the Kaggle.
Yeah. This is the data set from Kaggle directory, not from the system.
Okay, we have to download and we have to keep it. That name we have to give here.
Please, there
No.
will be time for question. Now let the lecturer finish the
No.
presentation, please. There will be time for questioning, please.
This data set
Let
which
the
will be
presentation
downloaded
finish, please.
at this
Thank you.
point, not in our system. Okay, this data set will be downloaded from the Kaggle. Okay, but not in the our system, not in the
Okay, sir.
local directory.
Okay, sir. Okay.
Okay, this is download for this variable. So the data set, just like if we have the data set in our system, for example, you can see in the past we were using the CSV file. So for that we were using read the file, and that file was existed in our local directory. But here we are downloading the data set from Kaggle directly and store inside the variable which you can see on the left hand side, not in our local directory.
Okay, sir. Got it,
Okay,
sir.
so this data set will be available in this variable, and this variable we will use for further process and the interpretation. Got it?
Got it, sir. Thank you.
Okay, thank you. Okay. Yes. So here you can see this is the variable, the data set is stored inside in this variable, and this is the path. If you are required to print the path to dataset file is this one, if it is required. Okay, so here this is the root dataset directory. We have two directories are there. Okay, one is the training path and other is the testing data path. Okay, that is also from this dataset. So you can see here the first one is the you can see in my local directory there was two different folders. In the same way, the data which is available at the place are in two parts is divided. One data set is used for the training and other for the testing. So these are the root of the dataset directory. And then after we can define class labels must match directory name. So in each folder, you can see there was 4 subdirectories. Okay, one is glioma, then meningioma, then we have the node tumor, then we have the pituitary. Okay, these 4 subdirectories, subfolders are there. Okay, and then you can see here we are using length function. Okay, how which is the size. Okay, so length function is there for the class, each one. There are 4 classes. Okay, then you can see here image size. There are 2 to 4. Okay, this is the target image with uh, width and height. Okay, so this is the size of each one. Then we have the image channel 3. Actually, each image has mostly we have red, green, blue images. 3 colors are there. Okay, there are 3 channels for based on color. Then we have the supported format. Sometimes we have the different formats. So here JPG, sometimes we have the JPEG, .png. So these are the formats which can support and we can use it. So most of the images which we are using are either it will be PNG and sometimes it can be JPEG or JPG. Okay, so TIFF and .bmp rarely used. So here we are using all the format which can be used to detect the images. Okay, so here we have the batch size. So batch size means the number of the samples per batch. We have 32. And epoch which we are using, epoch means the number of iterations. Maximum how many iterations we can use. These are 20 which we assign at the base. And validation split 20%, okay, for the training data for validation means testing. Okay, so as in the previous machine learning model we were using 20% for the testing and 80% for the training. So same thing is also at place. And you can see here the initial learning rate we are taking here 0.001 starting learning rate for Adam optimizer. Okay, see, if you here we are required Adam optimizer. Okay, so for that we can use the learning rate 0.001. But if you need some more experiment for the accuracy, you can change this value to 0.01 and you can see the complexity will be increased. So according to that, we have to change this value. Okay, so this value is appropriate for this Adam optimizer which we are using for this model. Okay, and you can see the call configuration, callback configurations. So early stopping prevent overfitting by stopping as we discussed yesterday. Okay, so by stopping trending when validation loss stop improving. So when the improvement is not there, in that case we have stopped the overfitting. So for that we are using and some testing are required. For that we are using the early stop monitor. How by using value loss. So metric to monitor for early stopping, and then we have the early stopping patience. We are taking here equal to 3 value. So number of the epochs to wait before stopping. Okay, so how many epochs we can use for the early stop. Then here are the learning rate reduction, reduce learning rate if validation loss. Okay, so here LR reduction factor we are taking 0.3. This is the multiply learning rate by this factor. Okay, as we are taking the learning rate is 0.001. So by this will be multiplied. And LR reduction patience we have to epoch to wait before reducing the learning rate. Okay, and minimum learning rate we have is this value you can see 1a minus 7, which is very, very small. Okay, so this is the minimum learning rate, prevent too small value. So from this we are not able to reduce learning rate. Then we have the model, best model path. Okay, these models we already defined from in the very beginning and we are using here. So these are the checkpointing. You can see the best result model.h5. This will save the best model during the training. And level encoder path, this will save the encoder for later use. Okay, and final mode model math model path. This will be the final model path. Brain tumor classifier ResNet 50.h5. So these model checkpointing are required for this deep learning. Then we have the Lime configuration. Lime configuration we are using for the local interpretable model, agnostic and explainable. Okay, so this will help us to expand the individual prediction. Just like we have the Lime num sample, we are taking 500 number of the perturbed samples to generate. and the other features we have a number of the top features to highlight. These are 10. So then we have the reproducibility setting, which is essential. Set the random seeds to ensure reproducible result across runs. So random seed we are taking here 32, and np dot random seed. These are the statements which are essential to use here. Okay. Then this is the visualization, and for the visualization you can see configure matplotlib and cporn for better looking plots. plt dot style dot use cporn v0 underscore 8 target, this is the color, and sns dot set palette hustle. So this will visualize the result. So these are the statements which you can see the all the type of the values which will be reflect at the base. So these are the some which we have assigned the values just like path, class, enum classes, join the class, then image processing, okay, size, sport format, okay, training, batch size, max epochs, how many epochs are required, learning rate, validation separate, all these values will print here. So when you will execute, actually this part is also taking some time when you will execute, but not fast as we do in machine learning models. Okay, so this will also the time consuming. When you will execute, you have to wait some time. So all the outputs regarding all these will be here, you can see. Okay, so here you can see this is the data set, the path is there, and okay, the path is from Kaggle Hub, and from there the data is used here. Okay, so there are 4 classes which we have shown in the very beginning: glioma, meningomia, node tumor, pituitary, etc. So all these are the 4 classes in our data set. Then you can see when image processing, so the size you can see 224 by 224 3. So actually one figure size we have is 224 by 224, and 3 is used for color. Okay, and these are the spot format which we use at its base. So this is the training base size which we use at its base. 32 epochs, 20 learning rate we are taking here 0.001, and validation split we are taking 20%. Okay, so all this information we are using to train our model. According to our input, all these are at this base when you will execute this shell. Okay, so these are the instruction from our side which we implement for this model. Then here data loading and data frame creation. So here what we have to do, the images are indexed into the structured data frame containing file path, class label. Okay, so actually there are 4 classes, so according to that labels will be assigned. Path is also essential, and data separate metadata. Okay, so for this we are using in section 3. Okay, so this is the data directory where the information is stored. These are the classes, and here is the supported format which we are using here. Okay, so this is the definition build data frame. This function we are using, and you can easily go through. So here all these will return the values. Okay, just like the shape, training, classes, length, count, shape, column, class distribution, all these will return here. Okay, so all these the commands which are essential. Okay, these are very quite simple. Just you are required to go through this file. Okay, train df build data frame for train. There are 2 types. One is training, and the other is test. So the same thing is there. Only the directory name will change here. You can see. In the first, you can see the train directory, and second one we have the test directory. So other features are same: classes, supported format, classes, supported format for both. Okay, one is for training and other is for test data frame. Okay, so when you will execute, this will return the building data frame. So here you can see the entire information about the data frame which we build based on the images which we have in our data set. So here you can get all the information. So here in the first, okay, you can see glioma, we have 1400 images, and meningioma, we have 1400. So each we have 1400 at its base, and the total file scan here are 5600. Okay, and valid images found, these are also 5600. Okay, so there is no invalid image. So this is from training. Okay, you can see from the entire path you can observe. So see user RAM, and this is a Kaggle Hub dataset. Then this is the directory where brain tumor MRI dataset is there, version 2, and the last you can see the training. Okay, so these are the dataset from the training, and this is the total images and valid images, both are equal. Similarly, for the testing, you can see the last one. So the testing images are here 400 for all 4 type classes, and total we have is the 1600. Okay, so here you can see the training data frame. Okay, so shape, size you can see 5600 by 4. As we have the 4 classes are there, 4 columns are there, and this is the class distribution, and you can see in each we have 25%. Okay, and for the testing you can see here. Okay, these are also size you can see 1600 by 4, and column and class distribution also you can see here. Okay, so this is the sample training data. So we are not able to see the entire data set, but here is the overview about the data set. Now we have the next level, image loading and pre-processing. Okay, so here all the images that to the MRI pre-processing improve the feature extraction, just like the image loading. Then we are required to normalization, brain region cropping. Okay, so we have to crop the images, resizing to resonate input dimensions, and last one we have the model specific normalization. So these features are required for deep learning. Okay, and to implement all these images and pre-processing, actually when we use the dataset which is inside the CSV file, we have to prepare the dataset to use for further process, just like cleaning the data. Okay, control the missing values, filling the missing values, or remove the missing dataset misinformation, or we are required to convert the just like string dataset into the numerical dataset. Okay, so these are also required here to usable dataset. So these are the pre-processing pipeline, which is essential to implement deep learning for image processing. And for that, we are required here the libraries and the modules. You can see the import CV2. This we have installed in our system. Okay, and NumPy we are using. Then from TD DM import TQ DM. Okay, so these are essential here. So what this will do, we are using crop brain region image. Okay, this function we are using to crop the image. So crop image to brain region using the contour detection and fast back to the original image if contour detection fails. So this is the entire process. Okay, the images just like some are the gray color. Okay, gray means just like in the very beginning we were using the black and white TV. Okay, so that was not the black and white, that was grayscale TV. Okay, so from white to black we have different colors. Okay, but that are light to dark black. Okay, so this is known as grayscale. Okay, so some images which are in black and white at some places are very dark place, some places it will be white, and in between there are some shadow colors are also there. Okay, so this will use CV2 color image, and this will read and convert in RGB to gray color. Okay, some images, if there are red, green, or blue color images, that will be used in convert in gray color. Okay, so here also you can see the blur. Some are the blur images threshold also we can use. Okay, so when we read the images in MATLAB, okay, so sometime if all the blue, all the color images, when we will import, so these will be divided into three colors: red, green, and blue. There are three rays are there. Okay, three layers are there. Okay, so if we convert all these images into grayscale, then these are highly useful to use for the interpretation and for further process. Okay, and sometimes the images contain some type of the noise, or sometimes the images are blurred. Okay, some type of the errors are there. So these also we can avoid or we can reduce by using several threshold. Okay, so here for the blur plus threshold for the better contour interaction, we are using CV2 Gaussian blur gray, and this is the threshold which we are using 5,5, 0. Okay, threshold we are using threshold gray 45 to 255. Okay, and CV2 thresh binary, and contour. Then we can have the CV2 find contour. So this is also the way how we can approximate and how we can manipulate if there are some type of the errors or the you can say the noise in the image. So this is the way how you can use and uh, remove the some type of the errors or the noise in the image. Okay, so this is the complete process, and here if the crop size is equal to 0, then return the image. Okay, so this is the function by using you can crop the image, and which is usable for our further process. Okay, so all these we are required to after that we are required to download. So all the images will be stored inside the DF, and then after we are required to download. Okay, so DF is the data frame of the images for the images, and image size you can see here 2 to 4, and pre-process FN none. So this will be the load and pre-process all the images from the data frame. This is the entire process which you can see: image, label, valid indices, failed file. Okay, so these will help us to read the image. This code is required here to read the image. Then we have to handle the channel. Okay, and then after we have the image is equal to 3. So see here, what is the meaning of image 4 equal to 4 equal to 3? See, uh, image 2. Okay, so if length image dot shape is equal to 2, grayscale, this is for grayscale RGB. Okay, RGB means red, green, blue. Then if you are coming at the place image dot shape 2, okay, 4, this will convert PGRA to RGB. Okay, so these are the some shape of the colors, and according to that we are required to convert. If we have image shape 2 which is equal to 3, okay, if this condition is satisfied, and we have already discussed about the if else conditions. So according to which condition is satisfied, which we have assigned for the different images, according to that these will store the image and handle the channel. Okay, so here these are the categories of the different type of the images. See here BGR to RGB. So this will if this is true, this is satisfied, then image will be CV2 CVT color image, and this is the function BGR to RGB. So this will convert in RGB. So for the different colors we are using these different conditions. Okay, and then after go continue. Yes, so all the images will create and the label will be assigned. Index will be also assigned to all the images. Then after when you will print here and execute all the entire set, and for all these we are using, see from this place, test the data. Okay, as we do in the machine learning model, the same process we are using here. One part is also we skip at this place. First, we are required to train the data set. Okay, here also we are using the same process: xtrain, ytrain, ra, train valid indices, load the images, train df, image size, and pre-process. Okay, so these are the we are using for training the image data set, and then test the data set. Here is the same statement to test the data set. Okay, then keep only the valid rows, train df and test df. Okay, so this statement you can see which we are using, train underscore df dot iloc. Why we are using iloc? We have explained this term in the beginning. So many terms which we have discussed in the previous are there, but only the model is different here at this place. Anyone please, why we are using iloc? Forget? What you can see here, we are using for the rows only, and then we can print. Okay, so this is the complete process, and when you will execute, so this is the time consuming part again. Okay, so this will when you will execute all these entire statement, partially I try to explain, some are unexplained. Okay, so when you will execute, okay, so here is the loading training rate, and you can see here successfully loaded 5600 are there. There is no fail data, and this is the size you can see. Okay, so there are total 5600 images. Size is 224 by 224, and 3 red, green, blue. And then this is the loading testing data. Okay, and you can see the information successfully loaded 1600, and testing is this one, and data loading complete is this one. This is the pixel range which you can see here. Okay, then we are required to label encoding. What is the meaning of label encoding? Why we need label encoding? Anyone please? We have already discussed this term in the previous session. I am audible?
Yes, sir.
Yeah, why we are using label encoding? We have at space only the images. Okay, we have some features, and when we apply any machine learning model. So the computer understand only the numbers. So labeling by using the label encoding, we assign some numerical values. Okay. So here also you can see the classification models required numerical labels. So all the features which we have inside our image data set, we have to assign some numerical label so that we can apply for training purpose. Okay. So the label encoding convert categorical tumor classes into the integer suitable for training. And this enable loss computation, probability estimation, confusion matrix generation. Okay, why we need? So everything is described at this place. Okay, so when you will apply the label encoding and all the images have there are some features, and we want to use all this data set for training purpose. So first we are required to convert this categorical information of the tumor classes into integer, and only then we can train the model. So with the help of label encoder, we are able to calculate loss computation, probability estimation, and confusion matrix generation. So if these are required, we have to convert all the categorical data into integer. Only then we are able to use. So what is the process? See here, the entire process is described here. We have to initialize it to map the class names to integer. For example, you can see there are 4 classes, right? So in Python, the index is starting from 0. So for first glioma, we are taking 0. Then meningioma for 1, and no tumor we are taking 2, and pituitary for 3. Okay, so in this way we have assigned these labels to all these type of the classifications, and only then we will able to understand, we are able to train the model. Okay, so here is the label encoder function, okay, which will be here stored at this place, and then fit and transform the training label. See here we are using label encoder for this one, then dot fit transform y train raw. Okay, so this will fit and transform the training label. Okay, so the label will be assigned to the entire images which whatever we have. Then it transform the testing label using the same encoder. Okay, same encoder we are using to transform testing. Okay, so here you can see the label encoder dot transform function is there for what? Y test raw. Okay, and then you can see convert it to one hot encoding categories. For example, you can see 0, we are using 1 0 0 0, and class 1 we are using 0 1 0 0. Okay, so the neural network requires this format for multi-class classification. We have 4 classes. Okay, so for the multi-class we are required. So here we have the white train categorical, 2 categorical to white train num classes. Okay, and 2 categorical y test. So we have y train and y test for both we are required to use here. Okay, so the one will be the y train categorical and the other will be the y test categorical. Then after print label encoding, okay, then print label encoding successfully, then what information we are required to print to understand. So all these input we assign at this place, label encoded successfully, then and label mapping string to integer, okay, index name, then print label array shape, y train encoded categorical, y test encoded, y test categorical. Okay, so all these will be printed when you will execute. Okay, so when you will execute, see the instruction or the input which we assign for our requirement according to our desire. So when you will execute all these values, will print here for the understanding. So you can see all the outputs are here. Okay, according to our input, which are essential. So here we have assigned the label mapping string to integer. So at this place you can see on the left side we have the string, and their integer values you can see 0, 1, 2, 3 to all. Okay, label arrays you can see here. Okay, y train encoded we have 5600. Y train we have the categorical are 5600 by 4, and y test we encoded are 1600. Okay, so here also you can see the class distribution encoded with respect to all the four classes: gliomia, meningiomia, no tumor, perturbability, etc. So we have this information according to the input which we are going to implement for our model. Okay. Then after that we are using build RESTnet 5.0 transfer learning model. Okay. So we are using here to train the model. So transfer learning uses to train convolution backbone. Okay. What is this one? Anyone can please expand or train convolution backbone? I want to take the help from our one participant who has worked on the deep learning. Sir, can you please expand this term? Anyone, please? Okay. Exact meaning also I skipped.
Hello, sir.
Yes, ma'am, please.
As per my understanding, whatever I have read here or there, it is something we know that convolutional neural networks are good for image processing. So some
Yes, yes.
pre-trained network on the some larger data set is used as a basic, and then we give our data set uh, for the
Yeah,
training.
this yes, you are right.
Yes.
So this is the uh, used for feature extraction part of
Yes.
the convolution neural network.
Okay, sir.
Okay.
Okay. Yeah.
When we are required to extract the features by using CNN,
Yeah.
so this will be used here. Okay.
Hmm.
So the sequence of the convolution layer is responsible for learning visual features from the images, and the backbone has already learned to use full images representation from the large data set. Okay, some
Yes.
are the yes, yes. So to extract the features when we are using CNN, so this is very highly useful and backbone of the same. Okay. And why ResNet 5.0? Sorry, I I have to share the screen. My screen is visible?
No, sir.
Okay. Yes. So here, the final classification layers are customized for MRI tumor classification, and why we are required ResNet 5.0. So this is the deep residual architecture, mitigates vanishing gradient, and strong patterned visual feature extractor, and effective for limited medical images dataset. Okay. So this is the process, how we can use, how we can implement. So build the ResNet transfer learning model we are required. So this is the function, definition build underscore ResNet 5.0 underscore model. So we are required to here name classes, number of classes, image size, okay, freeze based true. So the entire information to use, and what is the transfer learning, everything is defined here. So I can, what is the meaning of freeze based pool, all these are defined here. So I can skip this part. You can easily go through this one. So here, this is the first step. What we do in the first step, you can see here, load the pre-trained ResNet 5.0, weights are equal to ImageNet, okay, and include the top files, remove the final classification layer, and input shape, we have the image dimensions, 224 by 224 by 3. Okay, so one image size we have is 224 by 224, and there are 3 is used for 3 different colors: red, green, and blue. Okay, so base model we are using here ResNet. This is the model name. That's ImageNet, and include the top files. So this is the way how we can implement. Then we are required to freeze or unfreeze the base model. Okay, so this is the entire process: base model, trainable, not freeze base, and frozen count we have some 1 for 1 in the base model. So here we are using for loop. Okay, if not 1, trainable. Then also we have the trainable count sum 1 for 1 in the base model dot layer if 1 is trainable. Okay, 1 dot trainable. So this will, what values are required to print here for the understanding. See here. So n base model, which we are using, then total how many layers are there: frozen layer, trainable layer, and freeze strategy. Yes, no. So this will print when we will execute all these statement. In the third step, what we are performing, build custom head layers. Okay. We will add layers on the top of the ResNet feature extraction layer. This will allow us to perform our specific classification task. So this is the way how you can use a base underscore model dot input. This is the input layer for images. Okay, so X is equal to, we are using base underscore model dot output. Okay, so input will store, these are the input. Okay, and for the output, we are taking ResNet output, which is the size of 7 by 7 by 248 feature maps. Okay, we have to check this value. I don't know exactly, but I think previously when we execute, this will be there. Okay, so then we have to apply the global average pooling, and for that we have the function which you can see here, global average pooling 2D. Okay, name global average pool, and for X variable, this will store inside X. Then we are required to check the dash block for 2042 to 512. Okay, ReLU activation function is there. We are using to introduce for the non-linearity. Okay, and this is the way how you can use dash 512 activation ReLU. Okay, ReLU is the name of the activation function, and name dash or for the variable X. So this will, then after we are required to normalization. Okay, so the normalize activation, accelerate training, prevent vanishing gradients we are using here. So this is the name of the function for the same batch normalization. Okay, So when you will apply the Bayes normalization, these all together will execute, will perform their task by using this single function. Then it drop out. What we are required to drop out, randomly deactivates 50% of the neurons to prevent overfitting. Okay, so these will be drop out. So this is the way how you can use dropout 0.5 name dropout 1 x. So when we are training the model, in that case, randomly 50% of the neurons are to prevent, we are required to prevent overfitting. So when overfitting is occur, so we randomly drop out these values. Then we have the dash block 2, you can see here. So here we will apply the you can have the progressive reduction 512 to 256. Okay, so this will reduce the dropout to 0.3. Okay, so the same thing we are applying here, dance 256 activation value, same function we are using, and the name we have is same as we use at the base. Okay, so previously this was 512, and right now we have 256. So this will reduce to 0.3. Okay, so Bayes normalization we are using the same. Okay, so name BN2 and dropout 2. So then we have the output layers. So these are the some layers are there. Okay, these are the hidden layers which we are using, and this is the output layers. So outputs will be there: dense, num class, activation, softmax. Softmax is also, again we have the activation function, and we have studied. Okay, so name is output, and this is the final model. Create the model, combine all the layers into the model. Okay, so several layers we are using here to train the model, and all these layers are hidden. Okay, so after this is the last step to create the model. This is the way how you can create. So in the step 5, we will compile the model. So for the compile, we are using the optimizer, and as mentioned in the very beginning, Adam, we are using here adaptive learning rates for each parameter. Loss categorically cross entropy for multi-class classification, and matrices accuracy primary evaluation metric. Okay, so this is the model compile, how you can compile the model. See these lines. So first we are using the optimizer, and we have to call Adam. How you can do tf.keras.optimizer.adam. So Adam we are taking from the one of the optimizer name, and optimizers are taken from Keras. Okay, so then after learning rate, initial learning rate which we have taken at the base, loss categorical underscore cross entropy, and matrix accuracy from tf.keras matrix precision and recall, both are we are taking. Okay, so these calculations and the terms we have covered yesterday's lecture, and the same thing we are using at this place. Okay, so these the values after implementing the outputs which are required to print here for our understanding. So we want to print here the custom head architecture, then global average polling 2D, and dense 512, dense 256, and dense num classes. So all these will return the model and print here. So when you will execute, build the transfer learning model. Okay, so all these will you can see in this table. Okay, so this will start from just 1 minute. Yeah. So all these are the outputs. The total layers we have is when you will implement. Okay, and when you will execute, building model architecture is built up at this place by using all these optimizers. We are not required to choose how many layers are required total and how many are required to change. So according to the model which we are using here, optimizer, this will automatically choose and decide everything according to the model. Okay, so when you will execute, this is the building random transform learning model, which you can see the outputs. So base model we have RangeNet 50. Okay, so this is the ImageNet pre-trained model. So total layers are 175, frozen are 175, trainable are 0, and freeze strategy yes. So custom head you can see here. Well, average polling 2D we have this value. Okay, 7 by 7 by 2048. Okay, and dense value batch norm you can see the dropout is 0.5, and dense 256 value batch norm we have is dropout is 0.3. Okay, so this we have implement, and when you will get the model resonated transformer learning, so these are the layers, these are the output shape, these are the parameters, and these are connected. So when you will scroll down and come here at this place, yes, see these values, total parameters. Total parameters we have is 24772, 228. So these are how many weights are changed, how many you can say the neurons are taken, their weights, etc. How many are trainable them? These are the value 1, 182, 980. Non-trainable we have is 23, 589, 248. Okay, so these are the total parameter, trainable parameter, and non-trainable parameters. So these are the values which you can see by executing this one. Then we have the model training. Okay, so for the model training, we are required to update the model weights through back progression. Okay, yesterday we discussed about the what is the back progression. So when we will implement the back progression and we are not able to achieve the target value, the difference between actual value and the prediction value, we have to reduce the error or cost value. For that, we have to follow the back progression, which will be from right to left. Okay, so important concept which are here, which we are using, the loss function measures the prediction error. Optimizer update the weights. The optimizer which we are using, this will update the weights, and then first this will be from right to left. All the weights will be updated. Then this will again from left to right for the output. So all the weights will be updated. Then all the inputs will be there from left to right. Okay. So in this way, the model will be trained and they will be optimized. Okay, so optimizer will update the weights to achieve the target values to fit the model, and validation monitoring detect the overfitting, and early stopping improves the generalization. So here you can see all these values which we are required to train the model and we want to print. Okay, so here we have is the, you can see the configuring training callback, and the values which we want to print here, just like early stopping, stop training if validation loss improve, etc. You can see here. Okay, so here we have the defined the training callback. Here is the training callback. So callback will include early stopping. For the early stopping, we are using the early stopping function, monitor, patience, restore, verbose, and mode. Okay, so all the description about all these which we are using are described on this site. Okay, the monitor the validation loss, wait n epochs before stopping, restore the weight from best epochs, print the message, stop when metric stop, decreasing loss. So then the learning rate reduce the LR if the training plateaus. Okay, so here the function which we are using here is reduce LR on plateaus. Okay, so monitor, factor, patience, same variables are there. So this will monitor the same matrix, multiply LR by this factor and wait n epoch before reducing. don't go below this LR. Okay. So then we have the model checkpoint, which will include save the best model. Okay, where you can see here the best model path, monitor well accuracy. So file path will be save the model, monitor the validation accuracy, and only save if better than previous. Don't print the message and save mode max. Save when metric increase for the accuracy. So all these values will be printed here when you will execute after the training the model. So at this place the record training start, the timing, and all these values will print here. So this is the all information configuration training backbone. Okay, and here you can see this part. When you will execute this part, you have to wait about 2 to 3 hours, and can be more than 3 hours. Okay, so at this place when I will execute this part, so I have to wait about more than 3 hours for my system. Okay, so that depend upon the system's configuration. So according to that, the time can be increased or can be taken less according to your system. Okay, but according to my system, it will take about 3 hours plus. So what you can see here when you will apply. So a training sample we have 5600, and validation separate we have 32%, batch size 32, and maximum epochs we are taking 20, and learning rate we have is 0.001. So now the optimizer, the iterations, when to stop, everything is there. So this is the main part. This is the main part of the training to train the model. So when you can see in the first epoch, in the first iteration, see the values. Okay, so there are 140 to 140, and here you can see the step accuracy. Accuracy is 0.7362. Loss is 7545. Precision is 0.797691, and recall is 7120. So when the second epoch will start, okay, so these values which you can see here, these are the second epoch. Okay, see the difference here. The accuracy is 0.3762. Here the accuracy is 8132. Okay, here the loss is 0.7545. Here is the loss is decreasing, accuracy is increasing. Okay, here is the precision value. This will calculate everything automatically according to the optimizer which we use at this place. Okay, and when to stop, and we assign here 20 iteration, but when the model will be trained, this will stop. Not necessary that all the iterations will be used. Okay, so here you can see recall is 0.7946. Okay, so as soon as the iterations will go through, will increase. So in each iteration, the accuracy and loss, accuracy will be increased and loss will be decreased. Okay, so main we are concerned with accuracy and loss. Okay, so our main purpose is to reduce the loss function, to reduce the cost value, and increase the accuracy. So in each iteration, in each epoch, you can see the values of accuracy and loss are changing respectively. Okay, so here when you will come to yes. So here the value of accuracy is 0.9733, loss is 0.755, but here accuracy is 0.9783 and loss is 0.67. Okay, and same address space we have is this value 0.8702, and sorry, this is the precision, and here the accuracy is 0.9821, and here is loss, you can see 0.0539. But in at this space, you can see the accuracy is 0.9821, which is same as at this space, 0.9821. Okay, and if you will observe the loss value, so very small difference is there here. The loss value is 0.0539, but here is 0.0509. Okay, and also the other values just like precision and recall are also required to consider and understand. Okay, so here you can see at this place, this will epoch R11 is used early stop. Okay, restoring the model weight from the end of the best epoch. Okay, so here we assign the 20 epochs, but this is the early stop because the model is trained here. But also we have to check the validation by using the other values. Okay, whether it is accurate or not. Okay, so see here, learning rate is very small. The learning rate is very small, and value precision is 0.8800, and value recall is 0.870. Okay, so if for complete iteration, interpretation, we can take help from the ChatGPT also. This will give us the entire complete interpretation in very few seconds. I copied all this information, and here is the chat GPT. Just 1 minute. Okay. Interpret. Yes. So from this, what we can extract and what are the meaning of each values, precision, recall, etc. So this will demonstrate here very carefully. So the training log indicate that your model has learned the training data extremely well, but its performance on the validation data is noticeably lower. Okay, so the training performance is good. You can see the accuracy is about 98.21%. Okay, loss is very small, 0.0509, and precision value you can see the 98.30 for all the sample predicted as positive. 98.3 were actually positive, and recall value you can see 98.17. The model successfully identified 98.17% from the actual positive sample. And if you will see the interpretation, the model performed expertly well on the training set, suggesting that it has learned the training pattern effectively. But when you will see the validation performance, this is also very important for our model. Okay, so the validation accuracy we have is 87.41. The model correctly classified about 87 out of 100 unseen validation sample. And validation loss you can see here is 0.4172. The validation loss is much higher than the training loss. Okay, and validation precision is 88% among the samples predicted as the positive in the validation set. So 88% are correct. Okay, the model correctly identifies 87.05% of the actual positive data. So when you will overall compare, and here is the overfitting analysis. So you can see here the metric, the training is 98.21%, validation is 87.41%, difference is 10.80%. Okay, loss you can see, and you can see the large gap when you will compare 0.0509 and 0.4172. The difference between these two is large gap. We have to, this gap is very minimum. So from this, we can analyze that the model is not validated. Okay. the prediction rate or training rate is high, but when you will observe the difference between these two values, so this analysis part will let you know the model, how much the model is accurate. And also you can see the difference between a precision value for the precision, training and validation. You can see that is also 10.30%, 30%. Okay. And recall, you can see 98.17, and validation is at 7.05, but the difference you will observe 11.12. So you can see the gap between the training and validation matrix suggests moderate overfitting. Okay, so the model memorizes the training data very well. Its ability to generalize the unseen data is lower. The high validation loss compared to the training further support in the. Okay, so you can have the entire report about the model. So this will just you are required to take the help from the generative AI tool. This will very frequently interpret the all entire information which we get after training the model. Okay. So here, this is the best matrix. You can see the final matrix is there. Training accuracy, you can see validation loss, you can see validation accuracy, you can see. Okay, and you can compare all these value. All the training static is there. Okay. Then we have the model evaluation. So when you have the training and after that evaluation part is again very, very important. So in this case, in this we will discuss about the model evaluation matrix, accuracy, overall correctness, precision, fast positive control, recall. All these parameters we have studied in the previous session. Confusion matrix, okay, F1 score, recall, precision, accuracy. So these two terms we have discussed right now also. Okay, so here is the way how you can implement model evaluation. Okay, so here we have the functions which we are using. C, generate the prediction on the test set. Okay, Y prediction probability, model dot predict X test, verbose we are taking 0. Okay, and Y prediction class NP dot arg matrix. Okay, we are taking Y prediction probabilities, X is 1. So Y, what is the meaning of X is 1 and X is 0? What is the meaning of X is 0 and X is 1? What is the meaning of this one? X is 1. If you have the data set in CSV file, Excel file, okay, there are rows and column. Then 0 is used for either row or column. Okay, check it and the previous sessions when we use the matrix, how you can assess the how you can read the data from row or from column. Okay, here is also the same thing. Then we are required to calculate the overall matrix. Okay, so the test accuracy, you can see here accuracy score. So here we are using Y test Y prediction class and test precision. So here we are using precision function and Y test Y prediction average weighted and zero division is equal to 0. Okay, then we have the test call, recall score. So these are the way how you can apply, how you can calculate these values. Okay, test accuracy, test precision, test recall, test F1. And then here we are printing the all these values. Okay, so here we have the print class, the report. So the report will be printed here. and then come to here. So when you will execute, so these files, these cell, I do not execute. I execute only at this place. Okay, because this take about more than 3 hours, and then our session was start. So I stop at this place. But the output values are there. We can study all this. So you can see here, these are the evaluation on the test set for our model. Okay, so overall test matrix we can observe accuracy is 0.8944, precision we have is 0.9071, recall we have is 0.8944, F1 score we have is 0.8943. This is the detailed classification report. Okay, accuracy. If you will observe that F1 score is precision is near about 19. Okay, and the recall you can see here 0.741, 0.951, 0.88, and so on. If we need the complete interpretation, this will help us for better understanding. Can we check from this place? So this is the overall report of the class-wise performance we are required. Okay, so this is the class-wise. So we can easily interpret and we can check the values and interpretation. So metric is precision value is 94.03. Recall we have is 74.75, and F1 score is 83.29. So this is the class-wise. Okay, there are 4 classes. This is all about the glioma. Okay, and when the model predict glioma, it is usually correct 94% precision, and identifies only 74.75 of the actual glioma cases, and around 24% of the glioma tumor are misclassified as the other classes. Okay, similarly you can check the other reports of the other classifiers. Okay, so this will help you for the better understanding and how the model is more accurate, and final report also this will produce and reduce your time to understand the model. Okay, so this is the confusion matrix test. You can see here, this is the entire confusion matrix test. So you can see from this place, this is the first parameter, first class glioma. Then we have the meningioma, node tumor, and periodontitis, and same parameters you can see on the vertical line on the left hand side. Okay, and you can see the values which are inside. These values are high. Okay, here you can see the parameter glioma, and also at the base we have the glioma. So these are not much important because these are concerned with the same parameter. So we are required to check the other values except the diagonal values. Okay, this is the complete evaluation and to help you understand. Okay, so the main thing here is the confusion matrix values and how we can evaluate. That is very important. The values which we are getting. Okay, here is the Lime model. So why Lime model is required? This will help expand AI with Lime. Okay, so for MRI classification, this will help to validate the clinical relevance, whether the model is clinical relevance or not, identify discriminative tumor region, and improve the trust in the model decision. Okay, so this is also the important part of our training model when we are concerned with deep learning. So here I can skip all these and come to the last step. Okay, so the main thing here is the confusion matrix values and how we can evaluate. That is very important. The values which we are getting. Okay, here you can see the parameter glioma, and also at the base we have the glioma. So these are not much important because these are concerned with the same parameter. because this is the very long part. Okay, so when you will execute this shell, this will print all the values. I was not able to execute this shell. Okay, and this is the summary and the conclusion. So the meaning is here. So all the steps which are required according to get the summary, whether the model we are able to recommend or not. Okay, so I am trying to execute this file also, this shell, whether it is possible or not according to our model. If this is executed, generating the printing test on the set. Okay. I don't know how much time this will take. This is in the process. So all the values which we assign at the place will be calculated, and after computing the evaluation, and then this will return the value at this place. Okay, this is still in the progress, and the same after that, when this will be executed, you can try this part also, and the last step also. Okay, so yes, so all these steps are essential for the deep learning. Okay, when you will implement CNN. So during the very last time, I tried to present all the steps which are essential for the deep learning. Okay, some I have to skip because time is very less, and this model required more time to explain each step very clearly. Okay, still the model is not we are able to complete. So the file will be available for you, and you must try yourself. Okay, so when you will execute this file entirely, but be ready to spend at least 5 to 7 hours, and maybe more time is required to complete this file. Okay, so this is very crucial to explain everything, but I tried to present so that you can have some idea how you can apply CNN when you have the data set based on images. Okay, so this is the entire process. Now, if you have question, you can ask now. So, dear participant, this is all about the today's session. And sorry, all the things I was not able to explain very clearly because due to the less time and many concepts are there. Okay.
Explanation is excellent, sir. This is one object of my thesis in my PhD. One object.
Yeah. Thank you. But I feel sorry because a lot of time is required to present. Actually, I just work for 5 to 6 hours. So I was supposed to that 5 hours is enough time for me to prepare this file. Okay. But later on, when I started to work on it, and since morning I was working on it, but the part training part is very crucial and a lot of time is required. Okay.
In my university, sir, GPU we have. So what are the changes I have to make to run this program?
What changes? Okay. So if the questions this type you can ask from me tomorrow, I will clearly define.
Okay.
Okay. Because there are some questions which I have some doubt for me. So if I will give you the wrong answer, that is not fine for me.
Okay.
Okay. So if you have the questions which is clear to me right now, I will give you the answer. Otherwise, you can put the questions. I will try to give the answers before starting the tomorrow session.
Okay.
Okay. You
What is
can.
the
You,
Okay, Prof. Good evening.
yeah. Good evening. Good evening. How are you?
Fine, thank you. My question is, thank you very much for this experiment.
Yeah.
I saw that the epochs you assigned 20, but the training stopped at 11. How did you give that command for it to stop at 11 epochs?
Actually, the for the training and for the testing, the data set is divided into two parts. Okay, 20% very less data we are required to use for testing purpose only, and 80% data set is used to train the model. Okay, and here when the model is trained, okay,
Hmm.
uh, yesterday I show you the one image when the model is going to train. Okay, so when the curve
Yeah.
is horizontal to the parallel to the horizontal line. Okay,
Hmm.
so if the approaches are continuously are going there, but there is no training, then what is the purpose to use the furthermore approaches? So this must be when the model is trained, this model must be stopped. Okay, for this training purpose, when you can see the last two iterations, the values are similar. Okay, so when the values of accuracy and loss function are similar or very less difference, then it means the model is trained. Okay, after that, if uh, and this will automatically stop at this level when the values are repeated or the difference is very small. Okay, you got it. So the optimizer will do everything when the model is accurately trained. This will stop. And see the yesterday's lecture, some images related to uh, before uh, one is the overfitting, okay, and perfect fitting into the model. So these were the images inside the model. So when the model is trained, okay, a perfect fit. So in that case, this will be parallel to the horizontal line. So when it becomes parallel to the horizontal line, after that we are not required further epochs. So this must be stopped so that the complexity can be reduced or time can be saved. If we further the epochs will go to up to 20. Okay, so after 11 to 20 we are not required much uh, because the values will remain same. Okay, accuracy and loss function, there are no change. If there is no change after that, then what are the required to implement the epoch? So the optimizer which we are using here, that will automatically
The
stop
train.
when the values are
Yes, sir.
similar type, okay, and optimize the all type of the errors, accuracy, everything.
Thank you, sir.
Yeah. Okay, I can. What is the threshold? Okay, threshold we are using actually uh, when we have the some type of the error, noise in the image. Okay, just type you can see the blurred image, and we want to clean. If you are the you have studied about the image process, so what we do in the image process, we clean the image and the errors we can remove from the image data. Okay, so the when you will import the any image in any machine, just like I use in MATLAB. Okay, so in MATLAB when you will import the values will varies from I think 0 to 200 something, 245 something, etc. Okay, so the errors we can fix the threshold, so which values are required to remove. So this is the some process to assign the value, but the optimizer will do everything for our task. Dr. Chandar Pasekar. Yes, please. Dr. Chandrasekhar, please. There are so many questions in the chat box.
Yes, sir. We'll write tomorrow, sir, few doubts regarding how to run.
Sir, your voice is breaking, not clear.
So,
Hello?
sir,
Yes, please.
so to clarify, sir, few more we'll discuss tomorrow. Are you audible,
Okay.
sir?
Yes, 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 yes.
Okay, sir. Thank you, sir. Thank you for your presentation.
Thank you, sir. Thank you. So if do one thing, if you have the questions, so if you will submit me in the chat box in the WhatsApp group, you can share your questions. So this will help me. Yes, Himania. Himania, please unmute your mic. Himania, you are not audible to me. Himania, yes, you are not audible. Your mic is not working. Okay, for the hyperparameter, I will share which I have. Okay, so for my study, I did not, I never use this hyperparameter. I have to study also about this model, and then I can give you the answer. But I have prepared. I have the model. I will share with you. I upload. Okay, so all the things are described there. Sometimes when we have the more complexity, and we want to use one model for one part of the data set, and for the other data set, we are using another model. So in this way, we can use multiple models for the machine learning purpose. Okay, so you are required to go through the file. Okay, I also was not able to spend more time about this model. So sorry, I am not able to give the answer right now, but tomorrow I am sure I will give you. Okay. Any more question, please?
Sir, what is the system requirements to do these kind of projects? If possible,
Right now, the model which I present for CNN, and you can see other things are working in my system. And if you want to know my system, then this is i5 11th generation. Okay, and 8 GB RAM enough. But if you have more complex or large data set, and in that case, you may be required more configurations, and sometimes the GPU is not working for our system. Then also we can take help from the collab. Okay, when you will see in the collab for the training purpose, if our system is not compatible, then what you can do, you can see here, this is collab. You can see the collab.
yes, sir. Google Colab is there.
Yeah, Google Colab. Okay, so from the Google Colab, some free is available. I am using a Colab. So this is the Colab, okay, and yeah. So in the Colab, when you will open any file,
The screen is not sharing, sir.
Screen is not visible.
Yes, sir.
Okay, just 1 minute. I will take only 5 minutes. Okay. For this task, I will take only 5 minutes. Share the screen, and if I will come to here. Okay. Screen is visible or not? Not visible. Okay. So this is my Google. My drive. Colab notebook. Okay. So I can take any file. I can take any file. So you can see this file which I have opened in Colab. Okay, Colab is completely also based on Jupyter Notebook. Okay, so same thing which we have done in, yes, you can see here RAM. So here you can see RAM and disk size. Okay, GPU is not there. GPU is not showing. Okay, this also can help you when you have the large data set, and you can see that the RAM is available here 12.62 GB and disk size is 107.72 GB, which is free available. But sometimes our system, our data set is very high or large data set, so we can use paid version. Okay, we have to pay some amount to train our machine learning model. So GPU size according to our dataset we can purchase from, but first time this will provide you free. But second time or third time when you will use, we have to pay some amount. Okay, so right now I don't able to see the GPU. Okay, only we can see the RAM size and disk size. Okay, so this is all about the today's session. Sorry, I was not able to see the GPU. But if our data set is very large and we are not able to run in our system, then you can take help from the Google Colab. And the same thing which we can do in the system, we can do in the Google Colab, because Colab is also based on Jupyter Notebook. And sometimes if the GPU is required, one time this will free available. Okay, but after that we have to pay some amount to train our machine, because sometimes the data is so high, we are required to use continuously to train the model about sometimes more than 24 hours are required, sometimes 3 days are required. Okay, so continuously we are required to this type of the space is required. So our local machine is not suitable for this type of the data set. So we have to take the help from uh, Google Colab. We can use for our training. Okay, so we are not at this level, so that we are required to use Colab or how very large data set. Okay, so but there was my colleague Dr. Upendra Kaur. She is working in Kal University. One time she has very large data set and required to use a Colab machine, and she trained the model, but she have to pay the amount about more than I think 40 USD. Okay, so there the specific time is duration is given, depend upon the problem. So according to the need, we can take help from the Colab also. Before that, we must be able to use local machine to train the model, CNN, RNN, or ANN. Then as soon as the complexity will increase, we can go for the this type of the machine also. Any more question? Okay. So for the today, this is enough. And tomorrow there are some questions, and there are some questions in my mind also. We will cover it tomorrow before starting the session. It will take only just questions are required to discuss. Okay. So tomorrow is the last session of our this workshop. Okay, and we will start the session at the same time, 8 p.m. according to IST. Dear Face, we can conclude the session now.
Okay. As we conclude today's session, I would like to extend my sincere thanks to Dr. Meher Chand for today's insightful and engaging discussion on the practical applications of artificial intelligence and machine learning. Today's session brought together many of the concepts we have explored throughout this workshop and demonstrated how machine learning techniques can be used to tackle complex real-world classification problems. It was an excellent example of how data, algorithms, and computational intelligence work together to generate meaningful outcomes. One of the key takeaways from today's discussion is that machine learning is most impactful when applied to solve practical challenges. Understanding the complete workflow from data preparation to model development to evaluation and prediction is an essential skill for anyone looking to work in AI and data science. I would also like to thank all participants for your active involvement, thoughtful questions, and enthusiasm throughout the session. Your engagement continues to make these sessions interactive and rewarding. We hope today's session has helped strengthen your understanding of how machine learning concepts are translated into real-world solutions and applications. Thank you, everyone, and have a pleasant night ahead.
Okay, thank you to all and good night.
Thank you, sir. Good night, sir.
Good night, Ji. Good night. Good night, everyone.